Let's look at trigonometry, and more specifically right-angled trigonometry, and what Soh Cah Toa actually means. So we'll come to these definitions in a moment, but let's start with these triangles. We see that in this first triangle, we've got a right-angled triangle, and we've got some angle x. Now each of the sides in this triangle can be labeled as something in relation to this angle x. So the side that's opposite the angle x is this side here. If we call it O for opposite, then that's the side that is opposite angle x. The hypotenuse is the side that's opposite the right angle, and so in this case that's this side here. We can label it as h. And then the adjacent side is the side that's left over, or the side that's closest to the angle that's not the hypotenuse. So in this case we can label it as a. Similarly, we can label each of the sides of the remaining triangles as the opposite, hypotenuse and adjacent in relation to the angle x. So in this triangle, the opposite side is this side here. We label it as O. The hypotenuse is this side, and the adjacent side is the side that's left over. In this triangle, the opposite side is O here. The hypotenuse is this side h, and the adjacent is this side here. And then finally, in this triangle, the opposite side here is O. The hypotenuse is the side opposite the right angle, so we can label it as h, and the adjacent side is the side that's left over. So we have the sine function is defined as sine x equals to the opposite side over the hypotenuse, where sin or sine is the abbreviation for sine here. Similarly, the cosine function is defined as cos x equals to the adjacent side over the hypotenuse, where cos is the abbreviation of cosine, and the tangent is defined as tan x equals to opposite over adjacent, where tan is the abbreviation of tangent, and where x is just some angle. If we look at the first letter of each of the words within these equations, we get the following acronyms. For this first equation, we've got the first letter here as S, and for this word, the first letter here as O, and the first letter here as H. And so, taking all three letters together, we get the acronym SOH, which is the first part of what we've got here. For the second equation, again, take the first letter of each word, so C, A, and H, we get K, which is the second part. And then finally, for the last equation, the first letter here is T, first letter here is O, first letter here is A, and so we get TOA. And so an easy way to remember these equations is to use these acronyms, so Soh Cah Toa. So let's look at an example of how we can use these equations to work out a missing angle. So we've got a right angled triangle here with sides labeled as 3, 4, and 5, and we've got a missing angle x, which we're trying to work out the value of. First thing we should do is label each of the sides in relation to the angle x here. So the opposite side is this side here, which is labeled as 4. So let's write O here. The hypotenuse is the side opposite the right angle, which is this side here, the 5. So we'll label that as H. And the adjacent is the side that's left over. So in this case, the 3. If we use our three equations, then we can use any of these to work out the missing angle x here. So if we use the first equation, we have that sine x equals to the opposite side, so in this case the opposite side is 4, over the hypotenuse, which in this case is 5. We could also write equations for cos and tan as well. So for cos x, we have the adjacent side, which is 3, over the hypotenuse, which is 5. And then finally for tan x, we have the opposite side, which is 4, over the adjacent side, which is 3. Since x is the same in all three equations, if we solve any of these, we should get the value of our angle here. And each of these equations solved should produce the same answer. To solve this first equation, we need to get rid of the sign so that we are left with x on its own. And so in this case, the inverse of sine is something called sine inverse, which we can get on a calculator by typing shift and then sine. And so we apply sine inverse to both sides. Sine inverse is the opposite of sine, just like how multiplication is the opposite of division, and how addition is the opposite of subtraction. they're all inverses. So this leads us to x equals to sine inverse of 4 over 5, which if we put on a calculator, we find to one decimal place that x equals to 53.1 degrees. Similarly, the inverse of cos is cos inverse, and we can get this on a calculator by typing shift and then cos. So we apply cos inverse to both sides, and so we get that x equals to cos inverse of 3 over 5, which if we put on a calculator to one decimal place, we find that x equals to 53.1 degrees. And finally, for this last equation, the inverse of tan is called tan inverse. We get this on a calculator by typing shift and then tan, and so applying tan inverse to both sides, we get that x equals to tan inverse of 4 over 3, and so if we put this on a calculator, we find that x equals to 53.1 degrees to one decimal place. And so we see that all three equations lead to the same answer, and so our value for x here is 53.1 degrees.